Hello students, welcome to our student support program for additional mathematics grades 10 and 11. Our chapter for today is series and we are going to look at arithmetic sequences. We are going to look at the first part of the chapter, arithmetic sequences. So let us start. In today's lesson, we are going to learn how to recognize an arithmetic sequence, how to find a specific term in an arithmetic progression, and how to find an expression for Tn in an arithmetic progression. So what is an arithmetic progression? In any sequence, if the difference between any two consecutive terms is always the same, we then say that the sequence is an arithmetic sequence. Remember, a sequence is a list of numbers which obey a certain rule. Now, what are the notations which will be used in this session? So we are going to denote the first term by the letter A, the common difference by D, the last term by L, the number of terms by N, and the nth term by Tn. These are standard notations which will be used in the chapter Arithmetic Progression. Let us now have a look at some examples of arithmetic sequences. So part A, we have 1, 3, 5, 7. So here, what is our first term? The first term is 1, and we say that A is equal to 1. Now, what are we doing to get the next term? We can see that we have to add 2 to get the next term. So we say that the common difference, that is D, is equal to 2. Part B, 2, 6, 10, 14. So here, our first term will be 2, and we can see that we need to add 4 to get the next term. So A will be 2 and D will be 4. Part C, 40, 30, 20, 10. So can you try to find the first term? Yes, A is going to be 40. Now, what are we doing to get the next term? We are subtracting 10. So we will say that D is negative 10. In each sequence, we have observed that the difference between any two consecutive terms is the same. Now, how do we find D, the common difference? Usually to find D, we take the second term minus the first term, T2 minus T1, or we can even take the third term minus the second term, or in general, we say that D is equal to Tn minus Tn minus 1, where Tn will refer to the nth term. Now the formula for Tn. So in general, the first term will be denoted by T1 and it is going to be equal to A. The second term now will be A plus the common difference, that is A plus D. Now T3 will be the second term plus the difference. Now the second term is A plus D, which will give us A plus 2D. Similarly, the fourth term will be the third term plus D, that is A plus 2D plus D, which will give us A plus 3D. So in general, the formula for Tn will be A plus n minus 1 into D. So now we are going to look at some examples to see how the formula can be used. Example 1. For each of the following arithmetic progressions, find the first term, A, and the common difference, D. So let us look at part A. 5, 9, 13. What will be the first term here? A will be equal to 5. Now, how do we find the common difference? We take the second term minus the first term. Or we can even take the third term minus the second term. So common difference D will be 9 minus 5, which is equal to 4. Now part B. Negative 5, negative 2, 1. So our first term here will be negative 5. That is, A is equal to negative 5. To find the common difference, we are going to take T2 minus T1. That is negative 2 minus 5, which is going to give us 3. Part C. We have first term x plus y, second term 2x plus 3y, and third term 3x plus 5y. So A, the first term will be x plus y. Now, to find the common difference D, we are going to take T2 minus T1. That is 2x plus 3y minus x plus y. Simplifying, we get x plus 2y. Now we move on to example 2. Find the 10th term in the arithmetic progression 2, 5, 8, 11, and so on. Hence, find an expression for the nth term. So the arithmetic progression, also called AP, is 2, 5, 8, 11. Our first term, A, will be 2, and the common difference will be 5 minus 2, which is 3. Or we can also take 8 minus 5, which is 3. Or even 11 minus 8, which is still going to give us 3. So the formula for Tn is A plus n minus 1 into D. We need to find T10, the 10th term. So replacing the value of n into the formula, 10 minus 1, which is 9, T10 will therefore give us A plus 9D. Replacing the value of A by 2 and the value of D by 3, we get 29 for T10. We also need to find an expression for Tn. So Tn, the formula is A plus n minus 1 into D. We now replace A by 2 and D by 3. So we get Tn equal to 2 plus n minus 1 into 3. Simplifying, we get 2 plus 3n minus 3, which gives us 3n minus 1. We now move on to example 3. In an AP, the fourth term is 25 and the ninth term is 41. Find the 15th term of the AP. So here, we have been given the fourth term is 25. That is, T4 is 25. So you have a formula here, which is Tn equal to A plus n minus 1 into D. I will therefore replace n by 4. This will give me A plus 3D equal to 25. Now, the ninth term is 40. So T9 is 40. Replacing in the formula n by 9, we get A plus 8D equal to 40. So I'm going to label my equations 1 and 2. I need to solve these two equations simultaneously. So equation 2 minus 1 will give me 5d equal to 15 and d equal to 3. Now we are going to substitute the value of d into equation 1. I will therefore get a plus 3d, and d is 3, equal to 25. So a will be 25 minus 9, which is 16. Now we have been asked to find the 15th term. So T15 will give me a plus 14d. Replacing a by 16 and d by 3, I will therefore get T15 equal to 58. Moving on to example 4. In an AP, the third term is negative 7 and the common difference is negative 4. Find the 10th term of the AP. So let us have a look at the solution. The formula is here. Tn is equal to a plus n minus 1 into d. So the third term is negative 7. This means that T3 equal to negative 7. So we replace this in the formula and we get a plus 2d equal to negative 7. Now, the common difference is negative 4. So this means that d is equal to negative 4. I'm going to call the first equation equation 1. Now I will replace the value of d into equation 1. This gives me a plus 2 into negative 4 equal to negative 7. So a will be equal to negative 7 plus 8, which is 1. Now I need to find T10. So T10 will be a plus 9d. I replace a by 1 and d by negative 4. This will give me negative 35. So T10 will be negative 35. Now example 5. In an AP, the first term is 2/3 and the third term is 3/2. Find the 9th term of the AP. So this is a simple example. It's just that here we have to work with fractions. So let us have a look at the solution. The first term is 2/3, that is T1 equal to 2/3 or simply A equal to 2/3. Now the third term is 3/2. So T3 equal to 3/2. Here n is equal to 3. If I replace in the expression for Tn, I will get A plus 2d equal to 3/2, which I call equation 1. I replace the value of A into equation 1. 2/3 plus 2d equal to 3/2. So 2d will give me 5/6 and d will be equal to 5/12. Now I need to find the 9th term. So T9 will give me A plus 8d. Replacing the value of A and the value of d into T9, we get 2/3 plus 8 times 5/12, which is equal to 4. So here are some exercises for you to practice on arithmetic progression, finding Tn. So students, in today's lesson, we have learned how to recognize an arithmetic sequence, how to find a specific term in an arithmetic progression, and how to find an expression for Tn in an arithmetic progression. So students, we have come to the end of the first part on the chapter Arithmetic Sequences. Until we meet again, it's goodbye.